Picture this: an asteroid slams into the middle of the Pacific Ocean. There is a flash brighter than the sun, then an explosion so violent it makes our biggest bombs look like party poppers. A hole opens in the sea, water, steam, pulverized rock, and asteroid debris blast upward for miles. And then, of course, comes the thing everyone imagines first, a mega tsunami. But here is the weird part: the wave may not be the real killer. The deadliest danger might already be rising into the sky before the first coastline even sees water. Near the impact, yes, the ocean becomes a monster. The asteroid does not politely splash. It dumps insane energy into the water, flash-boiling part of it and blasting a temporary crater into the sea surface. Around that crater, the water collapses back in, rebounds, and creates chaotic waves that could be hundreds of meters high near the impact zone. For nearby islands or coastlines, this is not a bad beach day. It is total destruction. A wall of water can smash inland, rip buildings apart, and scour the coast clean. But disaster movies cheat a little. A tsunami does not stay the same size forever. As it travels across the open ocean, its energy spreads outward over a huge area. That does not make it safe, far from it. The wave can still refocus when it hits shallow water, bays, or certain coastlines. Some places thousands of miles away could flood horribly. But it is not one magical wall of water washing over every continent. The tsunami is terrifying. It is just not always the main event. Here is the twist. Some models suggest only a small fraction of the asteroid's energy becomes tsunami energy. A much bigger problem is what gets launched upward. The impact can vaporize seawater, seabed rock, and pieces of the asteroid itself. This creates a superheated plume packed with steam, salt, dust, aerosols, and rock particles. And if the asteroid is large enough, that plume can punch high into the atmosphere. So while everyone is staring at the ocean, the sky is quietly becoming the crime scene. The key word is stratosphere. That is the atmospheric layer above most weather. If particles stay low, rain can help wash them out. Annoying, messy, terrible, but temporary. But particles injected high into the stratosphere can stay there much longer. They spread around the planet. They reflect and block sunlight. And now the disaster is not just coastal. It has gone global. This is when an ocean impact stops being a wave story and becomes a climate story. If enough dust and aerosols spread through the atmosphere, sunlight reaching the surface drops, temperatures fall, growing seasons collapse. Scientists call this kind of scenario an impact winter. And no, winter does not mean cozy sweaters and soup. It means plants get less light, crops fail, forests suffer. And in the ocean, phytoplankton, the tiny organisms at the base of the marine food web, can crash because they also need sunlight. One rock from space can turn the lights down on the entire food chain. This is why the long-term danger is so nasty. The tsunami hits fast. The climate aftermath can attack slowly. Less sunlight means less photosynthesis. Less photosynthesis means less food at the bottom of the system. Less food at the bottom means everything above starts getting hungry. On land, that means crop failures and famine. In the ocean, it means the collapse of tiny plankton can ripple upward into fish, seabirds, and marine mammals. The wave is loud, the hunger is quiet, which is somehow worse. This is not just movie nonsense. The Chicxulub impact, linked to the extinction of the non-avian dinosaurs, blasted enormous amounts of material into the atmosphere. It helped trigger global darkness, cooling, acid rain, wildfires, and food chain collapse. About 75% of species disappeared. Now every asteroid is different. Size matters, speed matters, impact angle matters, ocean depth matters. But the big lesson is simple. For a truly massive impact, the ocean is not the shield people imagine. It is part of the launch system. So if an asteroid smashes into the ocean, yes, the tsunami would be horrific. Near the impact, it could erase coastlines. But for a big enough asteroid, the scariest part is not the wave you can see coming. It is the shadow you cannot outrun. The plume rises, the sky changes, the sun dims, and suddenly the whole planet is inside the disaster zone. So which is scarier, the giant wave or the quiet shadow after it?